And welcome viewers. Now we have to derive the dimensions of Young modulus, right? So always remember that the Young modulus we can use y to represent, we also use e to represent it. So let's say we are using y now to represent Young modulus equals to, so we have stress over what? Over strain. Now when talking about dimension, we're talking about the dimensional what analysis of what of this formula and what and this formula that is here. So note that your stress formula for stress is we have force over area, right? Now let's break this down first. Now let's go and get what the dimension of what of force. Let's go and get it first. So we have force equals to mass times acceleration due to gravity. Now when coming to dimension analysis, the mass remain m. What acceleration? We're going to find for what? For acceleration. Now let's go out to acceleration first. Acceleration equals to change in velocity over what? Over time. So we are going to be having this initial becomes 0. So it means that we only have v over what? Over t. Initial decrease to what? Decrease to 0. We only have v over what? Over t left, right? Now, note that formula for velocity is what? Is actually what now? Displacement over what? Over time. Now when talking about displacement, I'm going to be using what? L to represent for displacement. So I'm going to use L for displacement over y time become t. When it comes to dimensional analysis, displacement represented is what? With L, y time is what? Is t. Now moving forward now, you're going to be having velocity equals to, acceleration equals to, so we have L. Breaking this down, we are going to be having L times 1 over t will give us what? L over t. Mathematically, we're going to be having L times 1 over t simply means t raised to the power of minus 1. That is t raised to the power of minus 1. So therefore, we're going to be having it as L t raised to the power of what? Minus 1 for velocity, right? So this should be velocity, not acceleration. So velocity is equal to what? L t raised to the power of minus 1. Now let's come back to what? To our acceleration here. So remember that the acceleration is what? Acceleration is, we have it as what? V over what? Over t. From what you have in this place, tell you guys that this u change to 0. So only have v over what? Over t in acceleration. Then you come out to write acceleration equals to, what's our v now? Our v, we derive it as lt raised to the power of minus 1. So we have lt raised to the power of minus 1 over what? Over this t that is here. Now this t has a visible one, right? Now, this is t, this is under t here. When the power of this t is going to this up to meet this one that is here, it change to what? To minus, because it's positive in this place. So when this one is coming here now, change to what? To minus 1. So I'm going to be having a equals to lt raised to the power of minus 1 minus 1. So therefore, acceleration equals to lt raised to the power of minus 2. Now, we've solved for what? For acceleration, right? But don't forget that we are coming from somewhere. We are coming from force. So now come back to your force. So we take force equals to mass times what? Acceleration. So force will give us mass times, what's the acceleration now? Lt raised to the power of minus 2. So force will give us mlt raised to the power of minus 2. That's our what? Our force. But initially, we have to what? To get what? Dimension of what? Of Young modulus, right? And which we are doing for stress first. And stress gives us force over area. So now let's proceed with it now. We've got it for our force. So I'll now take my stress. We take stress equals to, now what's our force? Force is mlt raised to the power of minus 2, then over, now area, now we're going to use what? L square for area. We're talking about dimension. So the area becomes L square. So I'm going to have stress equals to, now this is L, is under L here. When the power of this L that is here, which is 2 here, when it's going up, it change to what? To minus. But don't forget that this one have visible 1 here. So you're going to be having m raised to the power of 1. When it's coming up to this place, change to minus 2. And we have t raised to the power of what? Minus 2. So our stress gives us m l 1 minus 2 give us what? Minus 1. Then we have t raised to the power of minus 2. That's for what? For the stress, right? But we have to do for what? For Young modulus, isn't it? Now let's go now. Since we are going to be having Young modulus equals to stress over strain. Now Young modulus equals to, what's our stress? Our strength is m raised to power minus 1, then t raised to power minus 2. Now, strain is what? Is extension over length. So I'm going to have Young modulus equals to m lt minus 1, m raised to power minus 1, t raised to power minus 2 over. This is becomes what? Becomes L. L also becomes what? Becomes L. This cancel out now. So therefore, Young modulus dimension is what? Is m L minus 1, t raised to power minus 2. That's the final answer. Don't forget to like my video, share and comment. Thank you.